Then I'm going to talk about geometry. Geometry. I have to introduce two new theorem. The first one is about similarity of triangles. Okay, two triangles. Okay, and there's three sides A and B and C, and this is angle alpha, beta, this is gamma and the beta. Okay, and I have another triangle. Okay, A prime, B prime, C prime, and this is a gamma prime, beta prime, and alpha prime. Okay, we said that these two triangles are similar. Similar means, you know, they look similar, right? And if that's a definition, if the corresponding angles are equal, so if alpha equals alpha prime, beta equals beta prime, gamma equals gamma prime. If they're similar, you just enlarge one triangle, shrink one triangle to get another one. Okay, now for two similar triangles, you can also use another property to describe it. Or if this is two equivalent, okay, this will be equivalent to the following: A over A prime equals B over B prime equals C over C prime. So those two conditions are equivalent. Okay, so if the corresponding angles are similar, then you say that the two triangles are similar, and the ratio of the corresponding sides are equal. Okay, that's the first property. Okay, we can use this to solve problem very quickly. You know, some use a similarity. Okay, for example, I just give you example to do that. Okay, this is a right triangle. Okay, and this side is 3, this side is 4, and this side 5, and I draw the line here. Here's x. Now, how do you find x? There's a couple ways to do, but let's use a similarity of triangle to get x. Okay, how do I do that? Well, you can take a look at this triangle, this small triangle, and I put it here. Okay, this side is x, right? The other side is 3, right? Remember, right? This just cut it and rotate. Okay. Then I'll just give an example. You know. Yeah. Then those two triangles are similar. The reason is, okay, this is the same angle, right? If this is alpha and this will be the alpha, okay, because you just cut it and rotate and put it there, okay, and this is 90 degree and this is 90 degree here. So this, if this is a beta, this is must be beta. Beta is 90 degree, you know, minus alpha. So those two triangles are similar, then the ratio of the corresponding sides will be same, okay, x over 4, and that is going to be 3 over 5, okay. So therefore, you will get x equals 12 over 5, okay. Okay, so that's what we get. All right, so this is a this is a problem solved using similarity of triangles. Okay. So yeah, here the question is find x. Okay. Now another important property is about the circle. So you have 2 points A and B. Okay, and here's another point P. Okay, we find out. Yeah, draw the line here. So I have another point. I use a different color. Here's a P prime. Okay, so this angle, let's call it alpha prime. This angle is alpha. Okay. We find out we always have the following theorem. Okay, alpha prime is always equal to alpha. Doesn't matter where's the point P. Okay. And more important, if you see the center, okay, and you connect it with this too. If that point is beta, then they're all equal to, not only they're equal half of the beta. Okay. Okay. This is the important fact in geometry. Okay. We will use that and to solve as a problem. Okay. So the following problem is a typical problem from math counts. Okay. Suppose you have this and you draw two lines. Okay. And this is A, it's a B. Okay. A and B and the C and the D. They intersect at point P. Okay. So we know that AP equals 3, PB equals 4, PD equals 5. Find PC. Okay. Okay. Now, how to solve this problem? Oh, somebody said, well, 2, 3, 4, 5, maybe 6, right? But whatever you claim, you have to prove it. Okay. So the idea is it's actually pretty simple. Okay. For geometry problem, you have to draw addition lines. Okay, connect the important points. This time I connect these 2 points and these 2 points. Okay, then you have a 2. Let me redraw. Let me draw another circle. I don't want to destroy the original picture. Okay, so I have a here. Okay, I draw this line, and the A and the B, and the C and the D and the P. Okay, so first thing I'm trying to draw 2 circles. Draw 2 lines. Okay, then I see I got 2 triangles. Okay, so this is a 1 triangle, right? Another triangle is going to be this one. Now, is there any similarity of the triangles? These 2 triangles. The answer is they're similar. Okay, so the triangle APC is similar to the triangle. Actually, I use a BPD. Okay, why? Okay, why? Well, first of all, these 2 angles are similar, right? Alpha, alpha, right? Are equal. Okay. Okay. Now look at this angle beta. This is a triangle, right? From A to C, then from C to D, right? So this should be the same. This should be the same here, beta, because they have the same common point, A and D. So just look like C and B are different points on the circle, right? So they have the same 2 foot points. So A and D. That's why this angle is the same. Then the sum of the 3 angles are equal to 180 degrees. So you can get that this is a gamma and that's a gamma. So A and D, I should use a D here, and this is a B. Okay, so A corresponds to D, and C corresponds to B. Okay, so those 2 triangles are similar. Then you can solve the problem easily, right? This is a 5, right? P and B, this is 4, okay? P and B, and this is a 5. And AP is 3, okay? So AP over DP, right? Because this 2 are corresponding side are equal to AC over DB, and equal to the corresponding side, the PC and the PB. Okay, so we don't need to know this part. Okay, but the AP is a 3 over 5. PC we don't know, and the PB is 4, and clearly, right? And the PC is going to be again, it's 12 over 5, right? So you find the answer. Okay. Got it? Yeah. Now, if you know how to solve this problem, the next problem will be much easier. Okay. This is from your homework. Okay. This is from your homework. All right. So now you draw the circle. Okay. This is a D, this is a A, that's a B and a C, and the intersects at the point E. All right, we are given AD equals AE, okay, equals 3. ED equals 4. BC equals 5. Find the area of the triangle BCE. So let's find out BCE. Wait a minute, BC, yeah, BC is this one. Okay, so I needed to connect those two lines. All right, so we are looking for the area of this triangle. Okay, all right. What we are given? AD is a 3, AE is also 3. So you get an isosceles triangle, right? And the ED get 4. Okay, those two triangles. Then BC is a 5, right? And you want to get a triangle. You want to find the area as a triangle. All right. So as we see that, you actually can determine all the sides of this as a triangle. Like this is X, this is a Y. But you probably don't need that, right? So why? The triangle AED is similar to the triangle CEB, okay? For the same reason. If this is alpha, that's alpha, right? And if this is beta, other one is beta because DAB and then DCB, they have the same foot points. So that's why they're similar. When they're similar, I have all these identities, right? 3 over 5 equals 3 over X equals 4 over Y. Okay. So from here you get right? You get X and Y, right? So X is going to be 5, clear, and the Y is going to be what? You know, Y and the 5 over 3 times 4, right? Yeah. So it's going to be 20 over 3. Okay. Yeah, 20 over 3, 10 is up there. Yeah. Okay, so you get X and the Y. Okay. So actually, you got an isosceles triangle. Okay. So this is a E, that's a C, that is a B. Okay. Here's a 5 and the 5. Yeah. So BC is also 5, right? BC is 5. So EC is 5, you already given. And the other side is a 20 over 3, right? So how do you find the area of the isosceles triangle? Well, all you need to do is to find the height, right? To find the height, use a Pythagorean theory. H is going to be H squared, right? Plus half of this, it'll be 10 over 3 squared, should be equal to 5 squared by the Pythagorean theory, right? Yeah. And to this triangle, right? So H is going to be 5 squared minus 10 over 3 squared. I have to simplify this. Okay. Now, 10 is going to be 2 times 5. Yeah, how do you simplify this, right? 2 squared, 5 squared, and 3 squared. So you can take 5 squared 3 square out, you get 3 square minus 2 square. Okay, so therefore you get 5 over 3 and square root of 9 minus 4. It's 5, right? 9 minus 4 is 5. Right, so this is a height. So once you get height, then you get area. Area of the triangle, right? BCE is a base, half of the base times the height. Okay. So it's going to be 50, right? 50 over 9 and the square 5. That's the answer given in the book. Answer key. Okay, so this problem involves lots of mathematics here. Okay, let's summarize. This involves lots of mathematics, right? You need to know Pythagorean theory because when you end up, when we get determine the result of the triangle. But most important thing is you should find out the two similar triangles. Okay, and then you can determine all the other sides of the triangle in the yellow color. Then once you know the 3 sides, you can find the triangles uniquely determined. So then you can find the area. But for this problem, you just use the Pythagorean theory. You can easily find the area. But my question is, if we are given an arbitrary triangle, let's just say 3, 5, and for example 6, okay? How to find the area? Okay, how to find the area? If the 3 sides are uniquely determined, right? How to find the area of this triangle? Okay, you say, well, I'm going to find the height. Yes, you can do that. Find the height. This is a possibility. Okay, so I'm going to show you the first method. You find the area. Okay, and this is height. As soon as find the height, then you can find the area. So this side is x, this side is y. So you write all the possible equations you can get, then you can find, right? So that's my first method. Okay, so you x plus y is 6. That's the first equation. You need the 3 equations in order to determine 3 unknown variables. Then h squared plus y squared equals 5 squared. And the x squared plus h squared equals 3 squared. So from here you can find the x, find the h. Okay, you find the h, then you solve. Then you can find you can find the h from these 3 equations. They're a little bit complicated, yes. Okay, so one can find the h. Okay, then the area. Okay. All right. So the second method is called the Heron's formula. Okay. Heron's formula says that if you have a triangle, okay, A and B and C, so the area is going to be S minus A, S minus B, S minus C. So S is half of the parameter. Okay. So for the above problem, if here's 3, here's 5, here's 6. So first of all, let's compute the S. Okay, 3 plus 5 plus 6 divided by 2. Okay, 14 divided by 2 is 7, right? So 7 is a number. Okay. Yeah. Then area is going to be 7 minus 3, 7 minus 5, 7 minus 6. Okay, you don't need to worry about 7 minus 6. It's a 7. Here's a 4. Here's a 2. Okay. Okay, great. So it's clearly 2 times square 14. Another 14 square root 2. Okay. Great. It's not 14 square root 2. 2 square root 14. Yeah. Okay. So that's 2 methods. Now, how do you get the Heron's formula? Is there anybody can prove it? If you can prove it, I hope you can take a picture and ask your parents to send them the picture to prove the Heron's formula. Okay, you know why? When you study mathematics, right, you have to ask yourself, and nobody can tell you, what they're going to do next step. Okay, if like the triangles can be uniquely determined by 3 sides. So if A, B, C are given, the triangle is uniquely determined. Of course, the area. Am I able to express the area in terms of A, B, C directly, right? You don't need to repeat it as trying to find the area over and over again using the above method. If you can think to that point, okay, then you have a potential to become a mathematician, okay, or any type of scientist. Scientists need this kind of, habit, okay. So when in the process where you're learning, you keep asking yourself, okay, and some new questions, and then you probably can solve it. Then you find, okay, it's already solved by Heron. That's fine. That's what he did, okay, by, couple 100 years ago, 300 years ago, yeah. So when he was doing exercise, for example, you are given triangle, and you always, use the first method of trying to find the area, okay, and that takes too much time, and finally he simplified his expression. Okay, he do not assume the 3 sides are specific numbers, just A, B, C. And he find the formula, and he simplify, and then finally simplify to the form which can be easily memorized. That's called Heron's formula. Okay. Right. So you do need if you solve a very specific problem, you can think about can you get a formula for the general case. If you keep doing like that, you will discover something new in the future when you grow up, okay? Yeah. Do not always work on specific number, and then some of them will be named after you, okay? So our next problem is this is a triangle, okay? Okay, this is A, B, and C. So a line bisects the larger acute angle in the triangle was a side of a length of 33, 44, and 55. Okay, that's I'm going to bisect this. So what is the length of the right? So this is a picture. Okay, so a lines bisecting the larger acute angle in a triangle was a size 33, 44, 55, and divides the opposite side into 2 segments. Okay, so divide. Okay, which one? Which is the length of the short segment of that side? So we are going to find out if this is the M. We find actually we want to find the AM. Okay, and MC. Okay, that's called the Y. Okay. That's called the X. X plus Y is 55. So once you find the one, you can find the others. All right. Now you can always assume this triangle, yeah, take a look at this triangle, okay? This triangle is very special, okay? Each side is a multiple of 11. So in other words, we know 3 squared plus 4 squared equals 5 squared. Of course, each term multiplied by 11, and you get 55 squared. So therefore, it is a right triangle, right? Okay. So I'll give you some hint. How can you use the property? Those two angles are same. Okay, when you think about that, right?
I don't think we can hear you.
All right, so I accidentally muted my microphone. Okay, so I redraw the picture. Okay, first of all, I have to claim. I draw additional line, and then draw a line from M to N so that MN perpendicular to BC. Then I realized that those two triangles are congruent because they're identical. The reason is the corresponding sides angle are equal, but the BM also is a common side. Okay, so that's why those two triangles first are similar, same size, so they're equal, identical. So BAM equals BNM. Okay, now I redraw the picture again. So I come over here. All right, because those two triangles are congruent, so BN should be equal to 33. Okay, BN is going to be equal to 33. But total length BC is 44. That's why this will be 44 minus 33. Okay, and the MN should be equal to AM, so that both X, I put X there. Then MC. MC, the total is AC is 55. Wait a minute. So this is right triangle. I needed to read them. It cannot be 45. This side, if it's a right angle, if that is right angle, this must be 55, okay? And that is 44. Yeah, it's impossible other side is wrong, right? So let me correct this. At the very beginning, you don't know, just 3 sides you put there, right? So now it's clear. Yeah. So this side must be 44, the 44 minus x. And here's a 55. So it's 22. It's a 55 minus 33, okay? All right, so BC is the longest one because this is this is the longer side of the right triangle. All right. Then you can find x quickly. Why? You use a triangle. You use this triangle, okay, to get x. Right. This is the right triangle. Each side is already expressed in terms of x. So x squared plus 22 squared equals 44 minus x squared. Okay. Right. And then you expand it's 44 squared minus 44 is 8 times 2, 88 x plus x squared. So x squared is gone. Then 88x equals 44 squared minus 22 squared. Right. Okay. Then x is going to be 44 squared minus 22 squared over 88. You can simplify it. How to do that? Each is a multiple of 11, right? 11 squared. So 11 squared, 4 squared, right? And 11 squared, 2 squared. Here's 11 times 8. Okay, right? So let's simplify it. 11 squared, 4 squared minus 2 squared is going to be 16 minus 4 is going to be 12. And here's 11, 8, right? So cancel this, right? And then, yeah. 3 and 2, right? So that's why it's a 33 over 2. So we find x. Right? So for geometry problems, it's very important to draw addition lines. Right? To draw addition lines connecting important points, but for this one, you draw the line perpendicular to BC. Then you use a property that 2 angles are equal. Otherwise, you cannot use that property. Okay. Otherwise, you cannot use. Now you can say these 2 triangles are congruent, and so you can express every at least many sides in terms of x. Okay. And then you find the AM. Okay. Okay. So once you find the AM, you can find the MC. Right. So this is a very interesting problem, and it was show up in the math competition. Right. So our next problem is as follows: in a right triangle, it's already given it's a right triangle. Okay. This is also a very typical problem. Okay. A circle is inscribed in the right triangle. Okay. So this is A, B, and C. Okay. AB is going to be 6. Right. And what we know is the radius of the circle is 2. Right. we want to find the area of the triangle. Okay, so this side is already know the 6, right? So you have to find a triangle, what do you have to do? You have to find the BC. It's a question of how to find it. Okay, so think about this, okay? And the problem can be, the question can be asked differently. They can ask you, oh, this is a right triangle. I only know one side, okay? And can you find the ratio of the area of the circle and the area of the triangle? Or more general, are you able to, even you get the general, right? Just we don't assume it's a size, any size. So this is the right triangle. Can we find the ratio of the triangle, the area of the circle and the area of the triangle? Okay, you can ask the question about that, right? Okay, so that's a research project. See, okay, this is more challenging, and maybe you cannot get maybe you get a number independent of the size of the triangle. Maybe you can assume this side is B, right? Do not assume B equals 6, okay, right? And then you can assume this, you can assume this radius, okay? Right now the radius is 2 and this side is B, okay? So can you find the ratio so can become something depends on B and R, right? So that's so you don't need to assume specific values to work on this problem, okay? Yeah, or you find the A, okay? All you needed to find the A, okay? Yeah, right, find the A. Yeah, let's say you can try to express A in terms of B and R, right? Then you can find the area. Area is A times B divided by 2, and the area of the circle is pi R squared. All right. So let's do this problem. Okay, we solve the problem using yeah. So very important property is this will be the height, the radius is the tangent point to the center is perpendicular to the side. So the area of the triangle is going to be half of A and B, right? But you can calculate the area in different way. Okay, so this area is going to be the area of these 3 triangles. Okay, this one of this is also half of, right? And A times R, right? That's the area of the one triangle, and half of the area of, let's call C, right? C times R, and half of the area of the B times R. So you get identity, okay? You get identity AB equals AR plus CR plus BR, okay? But on the other hand, okay, on the other hand, you also have the Pythagorean theory, A squared plus B squared equals C squared, okay? So, so you have 3 unknowns. So no, actually, you're assuming B and R, so you don't know. You have to find the A. right? You find A. So what you can get is, from here you can get C, right? You can get C, okay, right? Yeah. So CR equals AB minus A, R minus BR. And then C is going to be AB minus AR minus BR divided by R, okay? Okay, so you put it into the Pythagorean theory formula, then you get, yeah, then you will get, okay? So this is the identity you will get. And clearly you can find the A. You can express A in terms of B and R, okay? So we can express, this is a quadratic formula, okay? So you can, we can get definitely, yeah, we can express A in terms of R and B, okay? Right? Because that's the one single equation. So if you do not assume a special value, but in order to understand it a little better, I think we just use specific numbers, okay? So this side is 6, okay? The circle has a radius r equals 2, okay? So that makes computation much easier. So you draw the triangles, 3 triangles, and you connect the center to each edge, okay? And they're perpendicular. So this becomes the height of the 3 triangles, okay? Okay, becomes the 3 triangles. So therefore, if this side is A, right, and this side is C, so the area will be half of 6 times A, right? The triangle. But this triangle is decomposing into 3 triangles here already. Okay, 3 triangles already. So so this will be half of 6 times R, half of A times R, half of C times R. Okay, so much easier, right? Right now we cancel all the 1/2. So you get 6A equals 6R plus AR plus CR, right? Right? Since R is 2, so much easier, right? Since R is 2, so also have a, so R is 2, right? So it's 2, and 2 are divided by both sides by 2, 3A equals 6, and plus A plus C, okay? Okay? And then you move A to the left, it's 2A minus 6 equals C. Right? But on the other hand, right, you have a Pythagorean theory, right? So C is going to be 2A minus 6, right? You put it here, and then you look at both sides. Okay, 4A squared minus 24, right? And here's 36. So A, right? You get a quadratic formula, right? You get a quadratic formula, right? A quadratic equation. So 3A squared and minus 24A. And that's going to be 0, right? Because 36 both sides cancel out. So A is going to be 8. The reason is you get A squared minus 8A equals 0, and the A cannot be 0, so A must be equal to 8. So you get a very nice integer. Then once you get an A, then you can get the area of the triangle. Right, so this is a typical problem. Is there any other methods you can use? Possibly, but that's probably the simplest one. Okay. Okay. Now, our next topic is about 3D. Okay. we call the cone-like solid. If a cone-like solid is like that, first of all, you have a region in the plane. Okay, then this is two-dimensional, right? And another point in the space, you connect all the lines to the edge of the domain. So you get a cone. This is called a cone-like solid. Okay. In mathematics, you can show that if you draw the line perpendicular to the plane, okay, this is a height, and then the base area A is going to be the area of the base. Okay, H is the height. Okay, then the volume is going to be 1/3 of base area times height. Okay, this is a formula is true for all kind of cone-like solid. Okay, and especially as a pyramid. If the pyramid, okay, this is a pyramid, right? So how do you find the volume of the pyramid? Square based. If here's A is A, right? If you know the height H, then the volume is going to be 1/3 A squared times height. Sometimes you're not given the height. If you are told the edge length of each edges, right, then you can determine the height. Okay, you can determine the height. Okay. Yeah. So if this side is B, right? If this side is B, can you determine the height? Okay. Right. So here's a question. Okay. The pyramid, and I'm assuming a 10-10, and this is a pyramid. Okay. And this side is just assume that 20-20. And find the volume. Okay, how do you do that? Think about this. You see, based on the above formula, all you needed to find is the height. Okay. All right, so how to find the height? You draw the line from top, which length to the center of the square. Okay, so then you connect those 2 points, so you get a right triangle inside this this pyramid. Okay. But I needed to know that as a side, this is the H. How about the X? Then you draw the square, right? And this is what you can see. So this will be the X. Can you get X if this side is 10? The answer is yes, right? because this is also x. X squared plus x squared equals 10 squared. So x squared equals 10 squared divided by 2. Okay. Then you apply the Pythagorean theory to the triangle, the vertical right triangle. Okay. So h squared plus x squared equals 20 squared, right? And h squared equals 20 squared minus x squared is 10 squared over 2. Okay. Okay. So finally, h is going to be square over 20 squared minus 10 squared over 2. And then let's simplify a little bit. And the 20 is 10 times 2, right? So actually, you can take a 10 out. There'll be 2 squared minus 1/2. Right? It's 8. That's right. 4. Yeah. 20 is 2 squared. 2 squared times 10 squared. 2 squared minus 1/2. And that's 8. It's 7 over 2. It's a bad number, right? So anyway, you get 5. You have height. So the volume is going to be 1/3 of the base area times the height. Okay, so that's the volume. Right. So that's pretty good. So now I'm going to ask you to look at the following problem. This is a cube, okay? And you have A and B, C, D, E, F, H, G. Okay. We know that AB equals 12, BC equals 8. Okay. And AE equals 6. This is rectangular. Oops. All right, sorry for that. Yeah. BC equals 5 and A equals 6. Okay, this is a rectangular box, okay? I want to find out the volume of DH, B, and C. Okay, what is DH, B, and C? So it consists of those lines. Okay. Clear? Yeah. So let me color it. Okay. So this solid. Right. So yeah, I want you to look at this and try to figure it out by yourself. Right. Look at this, right? This is a cone-like solid. In order to find the volume, all you need to do is just find the base area and find the height. Right. What is the base area? Yeah, what is the base? This is a base. Right? What is the height? BC is the height. Okay. right? And then you draw the rectangle, right? Draw the rectangle, D and the C and the G and the H, okay? And the CH is this line. So this is actually the base, right? Okay, DC, what is DC? DC is equal to AB, so it's 12. What is DH? DH is going to be AE, so that's a 6. So now you find the area, right? Okay. So area of DHC, this triangle, is going to be half of 12 and 6. That's a 36. So that gives the base area. Then you know the height, then you find the volume. Okay, so the volume is going to be 1/3 the base area, 36. The height is BC, which is 5, and you multiply this out. Okay. Oh, 8. Yeah, yeah, this is, I put 8 here originally. Yeah, 6 is fine. Okay, it's not a big deal. Okay, if it's 6, yeah. BC, let me check. BC is 8. Yeah, that's what I put. Yeah, BC is 8. Okay, so after you multiply this out, it's 96. Okay. All right. Okay, at the end, I want to go back to the problem we did. Similar problem we did or discussed already. I have a 15, I have a 41, I have a 52. Okay. Find as many methods as possible to find the area of this triangle. Yeah.
Isn't the height supposed to be 5?
Yeah, I changed it. I changed BC to 8. Okay. Yeah. So it's okay. It's but our original problem is 8. So that's why I copied it wrong. Okay. Yeah. All right. So our next problem, this is one we discussed before, but my point is how many methods you can have to solve this problem. Okay. Well, first of all, you can use you can always use the Heron's formula, right? Okay. You can use the Heron's formula. Okay, the first one, right? So let's assume let's calculate the half of the pyramid, right? Which is going to be add them together, 15, 41, 52, and use a calculator, okay? So you get 54 quickly. Then the area is going to be, right, 54, and the 54 minus 52, 54 minus 41, 54 minus 15. You have to simplify this expression, and this actually becomes the integer. Okay, it's going to be 234. Okay, that's the first method. The second method. Yeah, let's try another method. Okay, the first method is by luck. You recognize that we know that 9 squared plus 12 squared equals 15 squared. Because I want to try to draw the line here. Here's a 15, here's a 41, here's a 52. So it's possible it consists of 2 special right triangles. So how can I get a 15, right? I remember 9 squared plus 12 squared equals 15 squared. Otherwise, how can I get 41, right? 9 squared plus 40 squared equals 41 squared. So I guess this 9 is the same. So I guess try this, okay? Here's a 9, and then 12 plus 40 is plus 40 is going to be 52. So this must be 12, this must be 40. And then, okay, then what is the area, right? So already know the its height is 9. So the area is going to be the base times 9 divided by 2, right? So it's going to be 234, okay? The third method is more standard. Okay, suppose we are not lucky, you get those so nice numbers, right? You still draw the line, draw the height, and here's x and y. So you get 3 equations. Okay, so first of all, x plus y equals 52. Second equation is x squared plus h squared equals 15 squared, and then y squared plus h squared equals 41 squared. Okay, and from here you can solve. You can solve the problem. How can I do that? Equation 1, equation 2, equation 3. I wish to find h, but I cannot do that immediately. If I find x and y, I can find h. Okay, so how can I do it? Okay, equation 3 minus equation 2. H is gone, so y squared minus x squared equals 41 squared minus 15 squared. Okay, right, so, well, that's equation 4, right? But the y squared minus x squared will be y minus x and y plus x. Okay, I keep writing this number. So, but the y plus x is already given, 52. So y minus x is 52, right? So it's going to be 41 squared minus 15 and divided by 52. Okay, that's equation 5. All right, equation 1 and equation 5, if you add them together, you get a y. Okay, and then that's right, so you get 2y, and then I have 52 plus, okay, it's getting more complicated, right? But anyway, you get a y, and now you probably have to simplify. The number is getting big and big, right? Yeah, so you got, you have to simplify it, and I have to tell you y equals, y is going to be 40, okay? Y is going to be 40. Eventually you can find it. So once you get a 40, then you can use any of the equations above equation. No, it's y squared plus 41 squared equals, h squared equals 41 squared. Okay, yeah, y squared plus, yeah, right? So already you know the y squared, so y is 41 squared minus y squared, 41 squared minus 40 squared. Okay, so you can get h if you want, okay? Yeah, you can get h using this, identity, okay? So it's going to be, it's this easy to compute. It's 41 minus 40 and 41 plus 40, which is going to be 81. So h is going to be 9 because 81, right? H squared is 81, h is 9. So you find the h, then you solve the problem. Okay. Okay, so the area is going to be 1/2 of 52 times 9, and that's 234. All right, so there are 3 methods for this problem. And the last one is more complicated. Actually, use the last method, you can derive the Heron's formula. Okay, you can try. Okay, yeah. Otherwise, you have to repeat this again over and over again to derive the Heron's formula to this particular problem if you don't know the Heron's formula. Okay. Okay. All right, so let's stop here.